So today's presentation will be about Physics Lab 2, which is basically a continuation from the charge types experiment we did in Lab 1. So as an introduction, as I said before, this experiment has the same foundation as the previous lab, but the only difference is that now we're calculating the charge on the tape as a whole instead of just treating it as a point charge. So for example, in the one, we just assume that the force being exerted by the tape was a point charge, but now we're taking into account the whole measurement. So as before, our mass is 0.0002 kilograms, and the length of the tape is 20 centimeters, which is also 0.2 meters. At the end, the result I got for the charge on the tapes was 2.349 times 10 to the negative 8 coulombs, which resulted on the electric force being 1.96 times 10 to the negative 3 newtons. Later on, I will show how I calculated these values and all of the data involved. So as a brief description of the experiment, since we already did this on the first lab, we basically had two pieces of tape of equal length that were charged with different charges when we ripped them apart from each other. So now that we ripped them apart, we now have a tape that is charged with positive charges and one that is charged with negative charges. Later, as the actual experiment, we put one tape above another and we observed how they interacted with each other. And we saw that the top tape went to the opposite direction of the force of gravity because of the force exerted by the bottom tape. On the bottom right, you can see a figure of more or less how the experiment looked like. So for the physics concepts, first we have Newton's third law, which is equal and opposite reactions. We can see this from the charges of the two tapes. So the two tapes basically exerted the same amount of charge into each other. Then we have that a system in equilibrium has all of its forces add up to zero, which is Newton's second law. And for instance, we can see this in the top tape when we have that the force of gravity equals the force exerted by the bottom tape. The only difference is that the direction is the opposite, but still the magnitude is the same. Then we have the electric force formula, which is force equals the charge times the electric field, which we will use later in our grade scope script. And lastly, we have superposition, which basically means that the sum of all the charges. So if we divide the tapes into 1,000 little pieces, then the final force will be the force of those little pieces added up. So here I have my grade scope script. So first we basically define the function for the electric field. We introduced our data. We also have a function for the line charges where we can specify how many divisions we want. And then we calculated the electric field by the charge times the electric field. So which is basically the equation I was talking about in the previous slide. And here on the bottom right, we can see this phenomenon, and we can see actually that the magnitudes equal to each other, which is 1.96 times 10 to the negative 3. Lastly, for the two questions. So what if we modeled each of our tapes as a single point charge? Well, mainly we can see the difference in the magnitude of the charges. So for the line charge, I got 2.349 times 10 to the negative 9, while on the point charge I got 1.4 times 10 to the negative 9. And this actually makes sense because in the line charge, since we're treating the whole, since we are grabbing the force of the whole tape, then it makes sense that it's greater because we are we're basically summing all of the force that's on the tape, which is what we talked about before about superposition. And basically, to the second to answer the second question, is just what we said. It's just what I said, and actually, this the line charge would be closer to the real value since it's precisely what we were doing in our experiment. In contrast, the point charge, while it can work to a certain extent, it's just a generalization of how the line charge works as a whole. Thank you.